Question 1. Comparative studies suggest that power supply unit (PSU) efficiency ratings, such as those designated by the 80+ program, have a direct impact on a computer system's operational costs and environmental footprint. When recommending a PSU for a client system upgrade, which of the following considerations best aligns with the principles of providing efficient and reliable hardware solutions? Option A. Choosing the PSU with the lowest wattage that meets the system's calculated peak power requirements, regardless of its efficiency rating. Option B. Selecting a PSU with a high 80+ certification rating E, G, Gold, or Platinum that comfortably exceeds the system's estimated peak power draw. Option C. Opting for a PSU with a basic 80+ White or Bronze certification, as this is generally sufficient for most consumer-grade systems. Option D. Prioritizing the PSU with the lowest purchase price, irrespective of its 80+ certification or brand reputation. Correct answer is B. Selecting a PSU with a high 80+ certification rating E, G, Gold, or Platinum that comfortably exceeds the system's estimated peak power draw. Explanation. This scenario presents a professional challenge because a technician is tasked with selecting a power supply unit (PSU) for a client system upgrade. The client has specific, albeit vaguely defined, requirements for efficiency and reliability, and the technician must navigate the technical specifications of PSUs in relation to these needs. The challenge lies in translating the client's general desire for good efficiency and longevity into concrete, technically sound decisions that align with industry best practices and potentially implied client expectations of value and responsible resource utilization, without overspending unnecessarily. The correct approach represents best professional practice because it directly addresses the client's stated need for efficiency by referencing the 80+ certification. This certification is a widely recognized industry standard that guarantees a minimum level of energy efficiency at various load levels. By selecting a PSU with a higher 80+ rating, e.g., Gold or Platinum, the technician is ensuring that the power supply converts AC power from the wall outlet to DC power for the computer components with less energy wasted as heat. This translates to lower electricity bills for the client and a reduced environmental impact, aligning with responsible IT practices. Furthermore, higher efficiency PSUs often utilize better quality components, which can contribute to increased reliability and a longer lifespan, indirectly addressing the client's desire for longevity. This approach is ethically sound as it prioritizes the client's long-term benefit and responsible resource management. An incorrect approach that focuses solely on the lowest wattage PSU that meets the system's immediate power draw is professionally unacceptable. While it might meet the basic functional requirement, it ignores the client's implicit or explicit desire for efficiency. This could lead to higher operating costs for the client and increased heat generation within the system, potentially reducing the lifespan of other components. Ethically, it fails to provide the best value and may be seen as a short-sighted solution that doesn't consider the total cost of ownership or environmental impact. Another incorrect approach that prioritizes the cheapest available PSU, regardless of its efficiency rating or brand reputation, is also professionally unacceptable. This approach disregards the client's stated interest in efficiency and longevity. Cheap PSUs are often built with lower quality components, leading to poor efficiency, increased heat, and a higher risk of failure. This not only fails to meet the client's needs, but also exposes them to potential data loss or hardware damage due to PSU failure, representing a significant ethical lapse in professional duty of care. The professional decision-making process for similar situations should involve a thorough understanding of the client's requirements, both stated and implied. This includes assessing the system's power needs, considering the client's priorities e.g., budget, performance, efficiency, longevity, noise levels, and then matching these requirements to available hardware specifications. Consulting industry standards like 80+ certifications is crucial for making informed decisions about power supplies. A technician should be able to explain the benefits of different efficiency ratings and their impact on the client's overall experience and costs, enabling the client to make an informed choice. Question 2. System analysis indicates a laptop fails to boot after a user upgraded the RAM with new SODIMM modules. The system was functioning correctly prior to the upgrade. The user is unsure if the new modules are compatible with the laptop's motherboard specifications. What is the most appropriate next step for a technician to take? Option A. Immediately replace the new SODIMM modules with a different set, assuming the current ones are faulty. Option B. Proceed with advanced system diagnostics without verifying the physical installation or compatibility of the new SODIMM modules. Option C. Attempt to boot the laptop with only one of the new SODIMM modules installed without first reseating both. Option D. Reseat both new SODIMM modules, ensuring they are firmly clicked into place, and then attempt to boot the laptop. The correct answer is D. Reseat both new SODIMM modules, ensuring they are firmly clicked into place, and then attempt to boot the laptop. Explanation. Scenario analysis. This scenario presents a common but critical implementation challenge in IT support, ensuring compatibility and proper function of hardware upgrades. The professional challenge lies in diagnosing a system malfunction after a memory upgrade, which can stem from various factors including physical installation, module compatibility, or system configuration. A hasty or incorrect diagnosis can lead to wasted time, unnecessary component replacement, and customer dissatisfaction. The need for precise knowledge of memory types, speeds, and motherboard specifications is paramount. Correct approach analysis. The correct approach involves a systematic troubleshooting process that prioritizes verifying the physical installation and then confirming compatibility. This aligns with best professional practices by addressing the most common and fundamental causes of failure first. Specifically, reseating the memory modules addresses potential issues with physical connection, which is a frequent cause of non-booting or unstable systems after hardware changes. If reseating doesn't resolve the issue, the next logical step is to consult the motherboard's documentation to verify that the installed memory modules, DIMM/SODIMM, meet the manufacturer's specifications for Type E, G, DDR3, DDR4, DDR5, speed, and capacity. This methodical approach minimizes the risk of further damage or incorrect assumptions, ensuring a stable and functional system. Incorrect approaches analysis. Immediately replacing the memory modules without verifying the installation or compatibility is a significant professional and ethical failure. It demonstrates a lack of systematic troubleshooting and can lead to unnecessary expense for the customer. This approach bypasses fundamental diagnostic steps and assumes a faulty component without evidence, which is unprofessional. Furthermore, it could lead to installing incompatible modules, exacerbating the problem. Attempting to boot the system with only one of the new memory modules installed without first reseating both, or without checking compatibility, is also an incomplete troubleshooting step. While testing individual modules can be part of a diagnostic process, it should be done after ensuring proper seating, and ideally after confirming compatibility. This approach might yield a partial diagnosis, but doesn't address the root cause if the issue is simply a poor connection. Ignoring the motherboard's documentation and proceeding with further troubleshooting without confirming memory compatibility is a critical oversight. The CompTIA, a plus certification, emphasizes the importance of understanding hardware specifications and compatibility. Failing to consult this documentation means potentially installing unsupported hardware, leading to instability or failure, and represents a failure to adhere to industry best practices for hardware installation and support. Professional reasoning. Professionals should approach hardware troubleshooting with a structured methodology. This typically involves 1. Understanding the problem. Gather information about the symptoms and recent changes. 2. Formulating hypotheses. Based on the symptoms, identify potential causes. 3. Testing hypotheses systematically. Start with the simplest and most common causes, e.g., physical connections, and progress to more complex ones, e.g., compatibility configuration. 4. Verifying the solution. Ensure the problem is resolved and the system is stable. In this case, the initial hypothesis should be related to the recent memory upgrade. The most fundamental checks are physical installation and compatibility. Question 3. To address the challenge of a workstation failing to post and display any video output after a power surge, a technician suspects a motherboard issue. The system exhibits no signs of life beyond the power LED illuminating. The technician has access to a known good power supply and a spare compatible motherboard. What is the most appropriate initial diagnostic step to confirm or rule out a motherboard failure? Option A. Reseat all internal components, including RAM, CPU, and expansion cards, before proceeding with further diagnostics. Option B. Boot the system into safe mode to check for driver conflicts that might be preventing video output. Option C. Connect a known good monitor and video cable to the system and attempt to boot, observing for any post-beep codes or diagnostic LEDs on the motherboard. Option D. Immediately replace the motherboard with the known good spare and test system functionality. The correct answer is C. Connect a known good monitor and video cable to the system and attempt to boot, observing for any post-beep codes or diagnostic LEDs on the motherboard. Explanation. This scenario presents a common challenge in IT support, diagnosing hardware issues without clear symptoms and under pressure to restore functionality quickly. The professional must balance the need for efficient problem solving with the risk of causing further damage or violating best practices. The core of the challenge lies in accurately identifying the root cause of a system malfunction, which could stem from various motherboard components or their interactions with other hardware. The correct approach represents best professional practice because it follows a systematic, logical troubleshooting methodology. This method prioritizes non-invasive checks and data gathering before resorting to component replacement. By first verifying power delivery and then examining post codes and BIOS settings, the technician is attempting to isolate the problem to the motherboard or a specific component connected to it without immediately assuming the motherboard itself is faulty. This methodical approach minimizes unnecessary hardware swaps, saves time and resources, and reduces the risk of introducing new issues. It aligns with the CompTIA, a plus emphasis on diagnostic skills and efficient problem resolution. An incorrect approach that immediately suggests replacing the motherboard without performing basic diagnostics is professionally unacceptable. This bypasses crucial troubleshooting steps, leading to potentially unnecessary expenses and downtime. Ethically, it demonstrates a lack of diligence and could be seen as unprofessional if the issue was a simple loose cable or a configuration error. It fails to adhere to the principle of least invasive first and can erode client trust. Another incorrect approach, focusing solely on software troubleshooting when hardware symptoms are present, is also professionally unsound. While software can cause system instability, the described symptoms, failure to post, no display, strongly indicate a hardware problem, likely related to the motherboard or its immediate peripherals. Ignoring hardware indicators and diving into software fixes is inefficient and demonstrates a misunderstanding of diagnostic priorities. This approach fails to address the most probable cause of the issue. A further incorrect approach, involving randomly reseating all components without a diagnostic plan, is inefficient and potentially risky. While reseating can sometimes resolve intermittent connection issues, doing so without understanding the specific symptoms or potential causes can be time-consuming and may not address the actual problem. It lacks the analytical rigor expected in professional IT support. The professional decision-making process for similar situations should involve 1. Gathering information, understand the reported symptoms and any recent changes. 2. Formulating hypotheses. Based on symptoms, create a list of potential causes, prioritizing the most likely. 3. Testing hypotheses systematically. Start with the simplest, least invasive, and most probable causes first. 4. Documenting findings. Keep a record of steps taken and results. 5. Escalating or replacing. If diagnostics point to a specific faulty component, proceed with replacement or seek further assistance. Question 4. Risk assessment procedures indicate that a user is experiencing significant system slowdown and frequent application unresponsiveness. The user has not reported any recent hardware changes or specific error messages, but the issue has become increasingly noticeable over the past week. The technician needs to determine the most appropriate initial diagnostic step to address the performance degradation. Option A. Install a new, higher-end graphics card to improve overall system responsiveness. Option B. Upgrade the system's power supply unit PSU to a more powerful model. Option C. Verify that the system's cooling fans are functioning correctly and that there are no obstructions to airflow, and check the system's resource utilization in Task Manager. Option D. Replace the system's random access memory (RAM) modules with a new set of higher capacity modules. The correct answer is C. Verify that the system's cooling fans are functioning correctly and that there are no obstructions to airflow, and check the system's resource utilization in Task Manager. Explanation. Scenario analysis. This scenario presents a common challenge in IT support where a user reports a performance issue that could stem from various hardware components. The technician must systematically diagnose the problem without making assumptions, ensuring a cost-effective and efficient resolution for the user while adhering to best practices for hardware troubleshooting. The challenge lies in identifying the most probable cause based on the symptoms described, rather than randomly replacing parts. Correct approach analysis. The correct approach involves a logical, step-by-step diagnostic process, starting with the most common and easily verifiable culprits for performance degradation, such as checking system resources and ensuring adequate cooling, is best professional practice. This aligns with the CompTIA plus methodology of isolating variables and eliminating potential causes systematically. It prioritizes user experience by addressing the issue promptly and efficiently, and it avoids unnecessary expenditure on parts that may not be faulty. This methodical approach is implicitly supported by CompTIA plus objectives, which emphasize troubleshooting methodologies and component identification. Incorrect approaches analysis. Replacing the RAM without further diagnosis is an incorrect approach because it assumes the RAM is the sole or primary cause of the performance issue without evidence. This can lead to unnecessary costs and labor if the RAM is not faulty. It bypasses crucial diagnostic steps that could identify a simpler or more likely cause, such as software conflicts or overheating. This is a failure in systematic troubleshooting, a core CompTIA plus competency. Installing a new graphics card without verifying the existing one is functioning correctly or is the bottleneck is also an incorrect approach. Graphics cards are often expensive components, and their failure or inadequacy might not be the root cause of general system slowness. This approach is inefficient and costly, and it demonstrates a lack of methodical problem solving. Upgrading the power supply unit (PSU) without any indication of power delivery issues or insufficient wattage is a fundamentally flawed approach. PSUs are typically replaced when there are symptoms of instability, random shutdowns, or when new, power-hungry components are installed. Assuming the PSU is the problem for general performance degradation is a significant diagnostic error and a waste of resources. Professional reasoning. Professionals should employ a decision-making framework that prioritizes systematic troubleshooting. This involves 1. Gathering information from the user about the symptom. 2. Establishing a baseline of normal performance. 3. Identifying potential causes based on the symptom. 4. Prioritizing diagnostic steps from simplest/most likely to most complex/least likely. 5. Testing each potential cause methodically. 6. Documenting findings and actions. This framework ensures efficient problem resolution, cost-effectiveness, and adherence to industry best practices, as emphasized in CompTIA plus training. Question 5. The control framework reveals that a user is experiencing significant delays when booting their computer and launching applications. The technician has confirmed that the operating system and all software are up to date and have been recently scanned for malware. The system currently utilizes a traditional hard disk drive, HDD. Which of the following actions represents the most effective and professionally sound approach to address the user's performance concerns? Option A. Recommend upgrading the hard disk drive HDD to a solid-state drive SSD. Option B. Perform a clean installation of the operating system and all applications. Option C. Suggest purchasing a new computer with a higher specification processor. Option D. Advise the user to close all running applications when not in use. The correct answer is A. Recommend upgrading the hard disk drive HDD to a solid-state drive SSD. Explanation. This scenario presents a common challenge in IT support where users' perceived performance issue may stem from hardware limitations rather than software configuration. The professional's task is to diagnose the root cause and recommend the most effective solution within the constraints of available technology and user needs. The challenge lies in balancing cost, performance, and user satisfaction while adhering to best practices for hardware upgrades. The correct approach represents best professional practice because it involves a thorough evaluation of the existing hardware's capabilities and limitations in relation to the user's workload. Recommending an SSD upgrade directly addresses a known bottleneck in HDD performance for typical desktop operations, leading to significant improvements in boot times, application loading, and overall system responsiveness. This aligns with the CompTIA plus exam's focus on practical hardware troubleshooting and upgrade recommendations, emphasizing solutions that provide tangible benefits to the end user. It also implicitly supports responsible resource management by suggesting an upgrade that extends the useful life of the computer rather than an immediate, potentially unnecessary, full system replacement. An incorrect approach of simply reinstalling the operating system without addressing the underlying hardware bottleneck would be professionally unacceptable. This is because it fails to resolve the fundamental performance issue, leading to continued user dissatisfaction and wasted technician time. Ethically, it could be seen as a superficial fix that doesn't genuinely solve the problem. Another incorrect approach, such as immediately recommending a full system replacement without investigating hardware limitations, is also professionally unsound. This is often more costly for the user or organization and bypasses a potentially simple and effective hardware upgrade. It fails to demonstrate a thorough diagnostic process and could be perceived as an attempt to generate unnecessary revenue. A third incorrect approach, focusing solely on software optimization without considering the hardware's role in performance, ignores a critical component of system speed. While software tuning can yield some improvements, it cannot overcome the inherent speed limitations of a traditional HDD for modern computing tasks. The professional decision-making process should involve a systematic approach. First, gather information about the user's complaints and typical usage patterns. Second, perform diagnostics to identify potential bottlenecks, including checking system resource utilization and assessing the health of the current storage device. Third, evaluate the most cost-effective and impactful solutions, considering both hardware and software options. In this case, recognizing the significant performance disparity between HDDs and SSDs for common tasks is crucial. Finally, communicate the findings and recommendations clearly to the user, explaining the rationale behind the proposed solution and its expected benefits. Question 6. Cost-benefit analysis shows that a user is experiencing significant slowdowns when running multiple virtual machines and complex design software. The current system has a mid-range processor from 5 years ago. Which of the following actions is the most appropriate first step for a CompTIA, a Plus certified technician? Option A. Recommend upgrading the processor to the highest-end model available for the motherboard socket, as this will provide the most significant performance boost for demanding applications. Option B. Advise the user to close unnecessary background applications and clear temporary files, as these actions are often sufficient to resolve performance issues without hardware changes. Option C. Investigate and test the system's RAM and storage, SSD vs. HDD, to determine if they are the primary bottlenecks before considering a processor upgrade. Option D. Suggest a complete system overhaul, including a new motherboard, CPU, and RAM, as the current system is likely too outdated to handle modern workloads effectively. The correct answer is A. Recommend upgrading the processor to the highest-end model available for the motherboard socket, as this will provide the most significant performance boost for demanding applications. Explanation. This scenario presents a common challenge in IT support, where a user's perceived performance issue might stem from various hardware components, not solely the processor. The professional challenge lies in accurately diagnosing the root cause without unnecessary expenditure, adhering to best practices for hardware upgrades and client satisfaction. The CompTIA, a Plus certification, emphasizes practical troubleshooting and understanding of hardware interdependencies. The correct approach represents best professional practice because it follows a systematic diagnostic process by first verifying the existing processor's capabilities against the software requirements, and then considering other potential bottlenecks like RAM or storage. A technician avoids premature and potentially costly component replacements. This aligns with the CompTIA, a Plus focus on efficient problem-solving and resource management. There are no specific U.S. regulatory frameworks directly governing processor upgrades for individual users in this context. However, ethical considerations of providing honest and effective service are paramount. An incorrect approach that immediately suggests a processor upgrade without proper diagnosis fails to adhere to professional troubleshooting methodologies. This can lead to unnecessary costs for the client and may not even resolve the underlying issue if the bottleneck is elsewhere. Ethically, this is a failure to provide competent service and could be seen as upselling without justification. Another incorrect approach that focuses solely on the processor's clock speed without considering other factors like core count, cache, or the specific demands of the user's applications is also flawed. Performance is a complex interplay of multiple factors, and a superficial assessment can lead to misdiagnosis. This demonstrates a lack of comprehensive understanding, which is a core tenet of CompTIA Plus certification. A professional decision-making process for such situations involves 1. Gathering information from the user about the specific performance issues and the applications they are using. 2. Reviewing system specifications and comparing them against the minimum and recommended requirements for the software. 3. Performing diagnostic tests to identify bottlenecks in CPU, RAM, storage, and GPU. 4. Recommending the most cost-effective solution that addresses the identified bottleneck, prioritizing upgrades that offer the most significant performance improvement for the user's needs. 5. Clearly communicating the findings and recommendations to the user, explaining the rationale behind the proposed solution. Question 7. Consider a scenario where a technician is tasked with replacing a faulty hard drive in a client's older desktop computer. Upon inspection, the technician discovers that the drive uses a SATA data connector, but the only available cables in their immediate toolkit are Molex power cables and older IDE data cables. The client is in a hurry and needs the computer operational as soon as possible. The technician is aware that a Molex connector is physically different from a SATA connector and cannot be directly plugged into the SATA port. What is the most appropriate course of action for the technician? Option A. Use an adapter that converts a Molex power connector to a SATA power connector, and then try to connect the IDE data cable to the SATA data port, hoping for a functional connection. Option B. Attempt to force the Molex connector into the SATA port, believing that some connection might be made to power the drive, and then use an IDE cable for data if it can be made to fit. Option C. Suggest to the client that they purchase a new computer, as the current one is too old to be worth repairing with the correct parts. Option D. Inform the client about the need for a proper SATA data cable, explain the risks of using incompatible connectors or makeshift solutions, and arrange for the correct cable to be acquired, even if it causes a delay. The correct answer is D. Inform the client about the need for a proper SATA data cable, explain the risks of using incompatible connectors or makeshift solutions, and arrange for the correct cable to be acquired, even if it causes a delay. Explanation. This scenario presents a professional challenge because a technician is faced with a situation where a client's immediate need for a functional computer conflicts with the proper, albeit slower, method of component replacement. The technician must balance the client's urgency with the integrity of the hardware and adherence to best practices, which are implicitly guided by the principles of responsible IT service, even if not explicitly codified by specific CompTIA Plus regulations. The ethical dilemma lies in choosing between a quick fix that might cause future problems and a correct procedure that requires more time and potentially incurs additional cost or client dissatisfaction due to delay. The correct approach represents best professional practice because it prioritizes the long-term health and reliability of the client system. Using the correct SATA cable, even if it requires ordering or waiting, ensures proper data transfer speeds, signal integrity, and physical connection stability. This prevents potential data corruption, intermittent drive failures, and physical damage to the motherboard or drive connectors, all of which could lead to more significant and costly repairs later. This aligns with the professional responsibility to provide durable and reliable solutions, minimizing future issues for the client. An incorrect approach involving forcing a Molex connector into a SATA port is professionally unacceptable due to several failures. Firstly, it demonstrates a severe lack of technical understanding and disregard for hardware compatibility, leading to potential physical damage to both the connector and the port. This can render the motherboard or the drive unusable, incurring significant replacement costs for the client. Secondly, it violates the principle of providing competent and professional service. Such a forceful and incorrect connection is a direct contravention of standard hardware installation procedures and could be seen as negligence. It also erodes client trust, as it suggests a willingness to compromise the integrity of their equipment for expediency. Another incorrect approach, using an adapter that is not designed for this specific conversion or is of poor quality, also presents significant risks. While adapters exist, using an incompatible or substandard one can lead to unstable connections, data errors, and even electrical issues. This falls short of professional due diligence in selecting appropriate components and ensuring system stability. The professional decision-making process for similar situations should involve a thorough assessment of the problem, identification of the correct components and procedures, and clear communication with the client. If the correct component is not immediately available, the technician should inform the client of the delay, explain the necessity of using the correct part for system integrity, and provide an estimated timeline for resolution. This transparent approach builds trust and manages client expectations, even when a delay is unavoidable. Prioritizing correct procedure over expediency, especially when hardware integrity is at stake, is a hallmark of professional IT service. Question 8. The investigation demonstrates that a user is experiencing intermittent unresponsiveness with their keyboard. The technician has confirmed the keyboard is not physically damaged, and the user has not reported any recent software installations that might conflict with the device. Which of the following is the most appropriate next step to diagnose the keyboard issue? Option A. Perform a full operating system reinstallation on the user's computer. Option B. Immediately replace the keyboard with a new one. Option C. Update the keyboard's firmware through the manufacturer's website. Option D. Connect the keyboard to a different computer to see if the issue persists. Correct answer is D. Connect the keyboard to a different computer to see if the issue persists. Explanation. This scenario presents a common challenge in IT support where a user reports a device malfunction, but the root cause is not immediately obvious and could stem from various components. The professional challenge lies in efficiently diagnosing the issue while adhering to best practices and ensuring user satisfaction. Careful judgment is required to avoid unnecessary hardware replacement or software reinstallation, which can be costly and time-consuming. The correct approach represents best professional practice because it follows a systematic troubleshooting methodology. By first verifying the physical connection and then testing the device on another system, the technician isolates the problem to either the device itself or the original system's configuration. This methodical approach minimizes disruption and accurately identifies the faulty component. This aligns with CompTIA, a plus principles of efficient problem solving and user support. An incorrect approach that immediately suggests replacing the device without basic troubleshooting fails to follow a logical diagnostic process. This can lead to unnecessary expenses for the user or organization and does not address potential underlying software or configuration issues on the original system. Ethically, it is unprofessional to recommend costly solutions without proper investigation. Another incorrect approach that involves immediately reinstalling the operating system is overly aggressive for a suspected input device issue. This is a time-consuming and data-destructive process that is not warranted at the initial stages of troubleshooting. It bypasses simpler, less invasive diagnostic steps and can lead to data loss for the user, representing a significant ethical and professional failure. The professional reasoning process for similar situations should involve 1. Gathering information from the user about the problem. 2. Verifying basic physical connections and power. 3. Performing simple diagnostic tests to isolate the issue, e.g., testing on another system, checking device manager. 4. Consulting documentation or knowledge bases if necessary. 5. Implementing the most efficient and least disruptive solution based on the diagnosis. Question 9. Upon reviewing the thermal management requirements for a new server deployment in a controlled data center environment, a technician is tasked with selecting the most appropriate cooling solution. The server will be running demanding applications continuously. The technician is considering several options: a high-performance liquid cooling system designed for enterprise servers, a standard air cooler with a large heatsink and fan, a low-profile fan designed for desktop PCs, and a passive heatsink with no fan. Which of the following cooling solutions is the most suitable for this scenario? Option A, a standard air cooler with a large heatsink and fan. Option B, a high-performance liquid cooling system designed for enterprise servers. Option C, a passive heatsink with no fan. Option D, a low-profile fan designed for desktop PCs. The correct answer is B, a high-performance liquid cooling system designed for enterprise servers. Explanation. This scenario presents a common challenge for IT professionals, selecting the most appropriate cooling solution for a critical server in a data center environment. The challenge lies in balancing performance, reliability, cost, and adherence to established best practices and potential regulatory considerations. Even if not explicitly stated as legal mandates in the CompTIA A+ context, these represent industry standards that can have downstream compliance implications. Careful judgment is required to ensure the longevity and stability of the hardware. The correct approach represents best professional practice because it prioritizes a solution that offers superior thermal dissipation and is designed for sustained, high-load operation, which is crucial for server environments. This aligns with the CompTIA, a plus emphasis on understanding hardware components and their optimal operating conditions to prevent failures and ensure system uptime. While CompTIA, a plus, doesn't enforce specific legal regulations, it promotes adherence to industry standards that contribute to operational integrity and data security, indirectly supporting compliance with broader IT governance principles. An incorrect approach that focuses solely on cost without considering thermal performance is professionally unacceptable. This could lead to hardware overheating, performance degradation, and premature component failure, resulting in costly downtime and potential data loss. Ethically, it represents a failure to exercise due diligence in protecting client or organizational assets. Another incorrect approach that prioritizes a solution not designed for continuous high-load operation, such as a consumer-grade cooler, is also professionally unsound. These coolers may not have the durability or cooling capacity required for a server environment, leading to similar issues of overheating and failure. This demonstrates a lack of understanding of component suitability for specific applications. Finally, an approach that ignores the potential for increased noise or power consumption without assessing their impact on the data center environment is incomplete. While not a direct regulatory failure in the CompTIA plus scope, it shows a lack of holistic system thinking, which is a hallmark of professional IT practice. The professional decision-making process for similar situations should involve 1. Understanding the specific hardware and its thermal design power (TDP). 2. Assessing the operating environment ambient temperature, airflow, rack density. 3. Evaluating the workload and expected load on the component. 4. Researching cooling solutions that are specifically designed for server or enterprise environments, considering their thermal performance, reliability, and power requirements. 5. Comparing solutions based on a combination of performance, reliability, and cost, with a strong emphasis on preventing failure and ensuring uptime. Question 10. Strategic planning requires a technician to assess the compatibility of existing hardware with new software requirements. A user reports that a critical business application, designed for modern operating systems and utilizing advanced graphics acceleration features, is failing to install or run correctly on their current workstation. Initial troubleshooting steps, including driver updates for the graphics card and operating system patches, have not resolved the issue. The technician suspects the problem lies deeper within the system's core architecture. Which of the following actions is the most appropriate next step to ensure the user can effectively utilize the application? Option A. Instruct the user to perform a clean installation of the operating system and the application. Option B. Suggest disabling advanced graphics features within the operating system's display settings. Option C. Advise the user to seek a less demanding alternative application that is compatible with older hardware. Option D. Recommend a motherboard upgrade that includes a chipset supporting the required graphics acceleration features and modern I/O protocols. The correct answer is D. Recommend a motherboard upgrade that includes a chipset supporting the required graphics acceleration features and modern I/O protocols. Explanation. This scenario is professionally challenging because it requires a technician to understand the fundamental role of chipsets in system performance and compatibility, and to make a decision that impacts the user's ability to run specific software. The CompTIA Plus certification emphasizes practical knowledge of hardware components and their interactions. A technician must be able to diagnose issues and recommend appropriate solutions based on the underlying hardware architecture. The correct approach represents best professional practice because it directly addresses the limitation imposed by the chipset's capabilities. Chipsets are responsible for managing data flow between the CPU, memory, and peripherals. If a chipset does not support a particular feature or speed required by the operating system or application, no amount of software configuration can overcome this hardware limitation. Recommending an upgrade that includes a compatible chipset is the only viable solution to ensure the software functions correctly and the system operates as intended. This aligns with the CompTIA Plus objective of understanding hardware compatibility and troubleshooting. An incorrect approach that suggests simply updating drivers or the operating system fails to recognize the fundamental hardware constraint. While driver updates are crucial for hardware functionality, They cannot add support for features that the chipset itself does not possess. Similarly, operating system updates are designed to work with a range of hardware, but they still rely on the underlying chipset's capabilities. Suggesting these as solutions without addressing the chipset limitation would lead to continued user frustration and an inability to resolve the core problem, potentially violating ethical obligations to provide accurate and effective solutions. Another incorrect approach might involve suggesting a software workaround that bypasses the need for the unsupported feature. While this might seem like a quick fix, it often leads to reduced functionality, performance issues, or instability, and does not truly resolve the underlying incompatibility. This demonstrates a lack of thorough understanding of hardware-software interaction and a failure to provide a robust, long-term solution. Professionals should approach such situations by first identifying the root cause of the problem. This involves understanding the system's hardware components, particularly the chipset, and their specifications. They should then consult documentation or reliable resources to determine if the existing hardware meets the requirements of the software or operating system in question. If a hardware limitation is identified, the professional should clearly communicate this to the user, explaining the technical reasons behind the issue. The recommended solution should be the most effective and practical one, even if it involves hardware upgrades, and should prioritize the user's ability to achieve their desired outcome with a stable and functional system. Question 11. Examination of the data shows a user reporting that their keyboard and mouse are not functioning correctly on their workstation. The user states that the devices were working fine yesterday but are now unresponsive. The workstation is a standard business desktop. Which of the following actions represents the most appropriate initial troubleshooting step? Option A. Immediately initiate a system restore to a previous point in time. Option B. Advise the user to purchase a new keyboard and mouse set. Option C. Check the computer's event logs for any critical errors related to USB devices. Option D. Verify that the keyboard and mouse are securely connected to the appropriate ports on the computer. The correct answer is D. Verify that the keyboard and mouse are securely connected to the appropriate ports on the computer. Explanation. This scenario presents a common challenge in IT support, diagnosing peripheral issues when multiple potential causes exist. The professional must move beyond simply identifying a faulty component to understanding the broader context of the user's experience and the system's configuration. The challenge lies in efficiently and accurately pinpointing the root cause without causing further disruption or data loss, all while adhering to best practices for user support and equipment handling. The correct approach involves a systematic troubleshooting process that prioritizes the most likely and easily verifiable causes. This aligns with professional best practices by minimizing user downtime, reducing unnecessary hardware replacement, and ensuring a functional outcome. It demonstrates a commitment to efficient problem resolution and customer satisfaction, which are core tenets of IT service delivery. An incorrect approach might involve immediately replacing hardware without proper diagnosis. This is professionally unacceptable because it can lead to unnecessary costs for the organization or user, and it fails to address potential software or configuration issues that might be the true cause. Ethically, it can be seen as wasteful and inefficient. Another incorrect approach could be to blame the user without thoroughly investigating the technical aspects, which is unprofessional and erodes trust. It also fails to uphold the technician's responsibility to provide expert assistance. The professional decision-making process should involve 1. Active listening to the user's description of the problem. 2. Gathering information about the specific peripheral, the computer system, and recent changes. 3. Formulating a hypothesis about the cause. 4. Testing the hypothesis through a series of logical troubleshooting steps, starting with the simplest and most probable. 5. Documenting the findings and the resolution. This structured approach ensures that all possibilities are considered and that the most effective solution is implemented. Question 12. Performance analysis shows that a small office network is experiencing intermittent connectivity issues, slow data transfer speeds, and occasional data corruption. The network consists of several computers connected in a linear fashion to a single coaxial cable, with terminators at each end. The IT technician has ruled out individual computer hardware failures and software conflicts as the primary causes. Which of the following actions would best address the root cause of these network performance issues? Option A. Replace the coaxial cable with a higher-grade shielded cable and ensure all connections are secure. Option B. Upgrade the network interface cards (NIC) in all computers to the latest high-speed models. Option C. Implement a quality of service (QoS) policy to prioritize critical network traffic. Option D. Migrate the network to a star topology, connecting each computer to a central switch. The correct answer is A. Replace the coaxial cable with a higher-grade shielded cable and ensure all connections are secure. Explanation. This scenario presents a common challenge in network management, identifying the root cause of performance degradation and selecting the most appropriate solution based on the underlying network architecture. The technician must move beyond superficial symptoms to understand the fundamental design of the network to effectively troubleshoot. The CompTIA A+ certification emphasizes practical problem-solving skills within a professional context, requiring technicians to apply their knowledge of network topologies to real-world situations. The correct approach involves recognizing that the described symptoms, intermittent connectivity, slow data transfer, and occasional data corruption, are highly indicative of issues inherent to a bus topology. In a bus network, all devices share a single communication channel. Collisions, signal degradation over distance, and the failure of a single segment can impact all connected devices. Therefore, identifying the bus topology and proposing a migration to a more robust topology like a star network, where each device has its own dedicated connection to a central hub or switch, directly addresses the fundamental limitations causing the performance problems. This represents best professional practice as it tackles the root cause of the issue, leading to a more stable and scalable network, and aligns with the CompTIA A+ objective of understanding and implementing efficient network solutions. An incorrect approach would be to focus solely on individual device configurations or software issues without considering the network's physical layout. For instance, suggesting that each affected computer needs a new network interface card (NIC) ignores the possibility that the entire network segment is compromised due to the bus topology's limitations. This is professionally unsound because it fails to address the systemic problem and likely won't resolve the intermittent issues. Ethically, it could lead to unnecessary expenses for the client without a guaranteed fix. Similarly, proposing to simply add more bandwidth to the existing bus network is a superficial fix that does not address the inherent collision domain and signal integrity problems of a bus topology, leading to continued instability and potential data loss. This is a failure to apply fundamental networking principles. Another incorrect approach might be to suggest a ring topology. While a ring topology offers some advantages over a bus, it still has single points of failure, a break in the ring, and can be complex to manage and troubleshoot compared to a star topology, especially in a modern environment. It doesn't offer the same level of resilience and ease of expansion as a star network. The professional decision-making process in such a situation involves a systematic approach. First, gather information about the symptoms. Second, investigate the existing network infrastructure, including its topology. Third, correlate the symptoms with the characteristics of the identified topology. Fourth, propose solutions that address the root cause, considering factors like cost, scalability, and reliability. And finally, communicate the findings and recommendations clearly to the client. Question 13. The efficiency study reveals that a technician is preparing to upgrade a client's desktop computer by replacing the motherboard. The client's current processor is known to be an Intel Core i5 with an LGA 1151 socket. The technician has a selection of new motherboards available. Which of the following actions is the most critical first step to ensure the upgrade is successful and the new motherboard will accept the existing processor? Option A. Check if the new motherboard has sufficient expansion slots for the client's peripherals. Option B. Confirm that the new motherboard has the same CPU socket type as the existing processor. Option C. Ensure the new motherboard's form factor is compatible with the computer's chassis. Option D. Verify that the new motherboard supports the same type and speed of RAM as the current system. The correct answer is D. Verify that the new motherboard supports the same type and speed of RAM as the current system. Explanation. Scenario analysis. A technician is tasked with upgrading a motherboard in a client system. The challenge lies in ensuring the new motherboard is compatible with the existing CPU, which is a critical component for system functionality. Incorrectly selecting a motherboard can lead to a non-booting system, wasted resources, and client dissatisfaction, impacting the technician's professional reputation and the company's standing. Correct approach analysis. The correct approach involves verifying the CPU socket type on the existing motherboard and then selecting a new motherboard that features the identical CPU socket. This ensures physical compatibility between the CPU and the motherboard. For example, if the current CPU uses an LGA 1151 socket, the new motherboard must also have an LGA 1151 socket. This aligns with the CompTIA+. Exams focus on hardware installation and troubleshooting, emphasizing practical, hands-on knowledge of component compatibility. There are no specific U.S. regulatory frameworks directly governing CPU socket compatibility for hardware technicians. However, adhering to best practices for hardware installation, as taught in CompTIA+, is the professional standard. Incorrect approaches analysis. Selecting a motherboard with a different CPU socket type, such as an LGA 1200 when the CPU is LGA 1151, is a direct failure of hardware compatibility. This would prevent the CPU from being installed, rendering the system inoperable. This is a fundamental error in hardware installation and troubleshooting, directly contradicting the knowledge expected of a CompTIA, a Plus certified professional. There are no specific U.S. regulations violated, but it represents a significant professional and technical failing. Choosing a motherboard that supports a different RAM type, e.g., DDR4 when the current RAM is DDR3, is also an incompatibility issue, but it is secondary to CPU socket compatibility for initial system boot. While important for a functional system, it doesn't prevent the CPU from being physically seated. This demonstrates a lack of thoroughness in assessing all critical compatibility factors. Opting for a motherboard with a different form factor, e.g., ATX when the case is micro ATX, might lead to physical installation problems within the computer case, but it does not inherently prevent the CPU from being installed on the motherboard itself. This highlights a failure to consider the entire system's physical integration, not just the CPU motherboard interface. Professional reasoning. Professionals should approach hardware upgrades by systematically identifying existing components and their specifications. This involves consulting system documentation, using diagnostic tools, or physically inspecting components. For CPU and motherboard compatibility, the primary determinant is the CPU socket type. A decision-making framework would involve 1. Identify current CPU and its socket type. 2. Research motherboards compatible with that CPU socket type. 3. Verify other critical compatibility factors: RAM, chipset, form factor, power connectors. 4. Select the most appropriate motherboard based on these criteria. Question 14. Analysis of a user reporting that their external hard drive is intermittently disconnecting from their Windows workstation. The drive is essential for daily backups and project work. The technician has confirmed the drive is recognized by the system, but experiences unexpected disconnections. What is the most appropriate initial troubleshooting approach? Option A. Suggest replacing the external hard drive, as intermittent issues often indicate hardware failure. Option B. Immediately advise the user to back up all data and perform a clean installation of the operating system. Option C. Verify the physical connection of the drive and its cable, test with a different USB port, and check the drive's power source if applicable. Option D. Inform the user that intermittent issues are difficult to diagnose and suggest they try to work around the problem. The correct answer is C. Verify the physical connection of the drive and its cable, test with a different USB port, and check the drive's power source if applicable. Explanation. Scenario analysis. This scenario presents a common but potentially frustrating situation for a support technician. The challenge lies in the intermittent nature of the peripheral issue, making it difficult to replicate and diagnose. The user's reliance on the device for critical tasks adds pressure to resolve the problem quickly and effectively. The technician must balance the need for thorough troubleshooting with the user's immediate operational requirements. Correct approach analysis. The correct approach involves a systematic, layered troubleshooting methodology that starts with the simplest and most common causes and progresses to more complex ones. This aligns with best professional practices for IT support, emphasizing efficiency and user satisfaction. By first verifying basic physical connections, then checking software drivers and operating system settings, and finally considering hardware failure, the technician addresses potential issues in a logical order. This methodical approach minimizes disruption and maximizes the likelihood of a swift resolution. CompTIA, A plus principles advocate for this structured troubleshooting process, which is universally applicable and efficient. Incorrect approach is analysis. Immediately suggesting a complete system reinstall without attempting basic troubleshooting is a failure of professional responsibility and efficiency. This approach is overly aggressive, time-consuming, and potentially disruptive to the user's workflow, as it involves significant data backup and restoration. It bypasses simpler, more likely solutions and represents poor judgment. Furthermore, it could be seen as a failure to provide adequate support by not exhausting less invasive diagnostic steps. Replacing the peripheral without proper diagnosis is also professionally unsound. While it might resolve the issue, it doesn't confirm the root cause. If the problem lies elsewhere, e.g., a faulty USB port on the computer, a driver conflict, replacing the peripheral is a waste of resources and does not educate the technician or the user about the actual problem. This approach lacks analytical rigor and can lead to unnecessary expenses. Ignoring the user's report and assuming it's a user error is a direct violation of professional customer service standards. Every reported issue, especially when it impacts productivity, warrants investigation. Dismissing the user's concerns without any attempt at diagnosis is unprofessional, erodes trust, and fails to address a potentially legitimate technical problem. This demonstrates a lack of empathy and a disregard for the user's experience. Professional reasoning. Professionals should approach troubleshooting by following a structured methodology. This typically involves 1. Identifying the problem, gathering information from the user. 2. Establishing a theory of probable cause based on symptoms and common issues. 3. Testing the theory to determine the cause, performing diagnostic steps. 4. Establishing a plan of action to resolve the problem and implement the solution. 5. Verifying full system functionality and, if applicable, implementing preventive measures. 6. Documenting findings, actions, and outcomes. This systematic process ensures that all potential causes are considered, resources are used efficiently, and the most effective solution is implemented. Question 15. Process analysis reveals a client requires an upgrade for their existing small form factor PC. They want to ensure the new system can accommodate a high-performance graphics card and at least 2 additional storage drives while maintaining a compact footprint. The technician is considering different motherboard and case combinations to meet these requirements. Which combination best balances the need for expandability with the constraint of a small form factor? Option A, a mini ITX motherboard and an ATX case. Option B, a micro ATX motherboard and a micro ATX case. Option C, a mini ITX motherboard and a mini ITX case. Option D, an ATX motherboard and an ATX case. The correct answer is B, a micro ATX motherboard and a micro ATX case. Explanation. Scenario analysis. A technician is tasked with upgrading a small form factor PC for a client who requires maximum internal component compatibility and future expansion potential within a limited physical space. The challenge lies in balancing the client's desire for a compact system with the need to accommodate a specific, potentially larger, graphics card and additional storage drives. Misjudging the form factor compatibility could lead to a system that either cannot house the necessary components or is unnecessarily bulky, failing to meet the client's primary requirements. This scenario demands a thorough understanding of how different motherboard and case form factors interact and the physical limitations each imposes. Correct approach analysis. Selecting a micro ATX motherboard and a compatible micro ATX case is the best professional practice. This approach offers a good balance between size and expandability. Micro ATX motherboards are smaller than ATX but larger than mini ITX, providing more expansion slots, typically up to 4, than mini ITX, which is crucial for accommodating additional components like a larger graphics card and potentially a sound card or capture card. Micro ATX cases are also more compact than standard ATX cases, but generally offer more internal space and better airflow management than mini ITX cases, making it easier to install larger components and multiple drives. This choice directly addresses the client's need for expandability within a reasonably compact footprint, aligning with the goal of a functional and future-proof upgrade. Incorrect approach is analysis. Choosing a mini ITX motherboard and case would be a regulatory failure in terms of meeting client requirements and professional diligence. While mini ITX is the most compact, it severely limits expansion, typically offering only one PCIe slot, which may not be sufficient for a desired graphics card and other peripherals. Furthermore, the extremely limited space within mini-ITX cases often makes installing larger components difficult and can lead to thermal issues, impacting system performance and longevity. This approach fails to provide the necessary expandability the client implicitly requested by wanting to upgrade and potentially add components. Opting for an ATX motherboard and a standard ATX case, while offering maximum expandability, would be a professional failure in this context. The client specifically requested a small form factor PC, and an ATX setup by definition is not considered small form factor. This would result in a significantly larger system than necessary, potentially exceeding the client's spatial constraints and failing to meet the core requirement of compactness. It demonstrates a lack of attention to the client's stated needs and a disregard for the small form factor specification. Selecting a mini-ITX motherboard with an ATX case is an incompatible and unprofessional approach. A mini-ITX motherboard is designed to fit into mini-ITX cases, which have specific mounting points and dimensions. While an ATX case might physically accommodate a mini-ITX board, it would likely result in poor cable management, inadequate airflow due to the board being undersized for the case, and a generally unprofessional build. More importantly, it fails to leverage the benefits of either form factor effectively and does not address the core problem of balancing size and expandability in a small form factor context. Professional reasoning. When faced with a client request involving specific hardware constraints and desired outcomes, a technician must first thoroughly understand the implications of each component choice. This involves analyzing the physical dimensions, expansion capabilities, and thermal considerations of different form factors. The technician should then map these technical specifications against the client's stated needs, prioritizing solutions that best meet all requirements. In this case, the client's desire for a small form factor, combined with the implied need for upgradability points towards a balanced solution like micro ATX, rather than the most compact mini-ITX or the largest ATX. Professional decision-making involves clear communication with the client about the trade-offs of each option, and selecting the solution that offers the optimal blend of performance, expandability, and form factor adherence. Question 16. Market research demonstrates that a significant portion of users in a corporate environment are experiencing intermittent network connectivity issues. A senior manager, frustrated by the delays, asks a junior IT technician to just bypass the firewall for a bit on a specific user's workstation to see if that resolves the problem, stating it's a temporary measure for a critical project. The technician knows that the firewall operates at the network and transport layers of the OSI model, and that bypassing it could expose the workstation to external threats. What is the most appropriate course of action for the technician? Option A. Attempt to reconfigure the firewall rules to allow specific traffic for the user's workstation without fully bypassing it, hoping this will resolve the issue. Option B. Lightly refuse the manager's request, explain the security risks associated with bypassing the firewall, and offer to perform a systematic network troubleshooting process starting from the physical layer upwards. Option C. Advise the manager that the issue is likely with the user's application layer software and suggest they focus on that instead. Option D. Immediately bypass the firewall as requested by the senior manager to ensure the critical project is not delayed. The correct answer is B. Politely refuse the manager's request, explain the security risks associated with bypassing the firewall, and offer to perform a systematic network troubleshooting process starting from the physical layer upwards. Explanation. This scenario presents a professional challenge because a technician is being asked to bypass standard security protocols for convenience, potentially compromising data integrity and network security. The CompTIA A+ certification emphasizes ethical conduct and adherence to best practices, which includes understanding and respecting the layered security provided by network models like OSI and TCP/IP. The technician must balance the immediate need for access with the long-term implications of security breaches and compliance with industry standards. The correct approach represents best professional practice because it prioritizes security and data integrity by utilizing established troubleshooting methods that respect the layered nature of network communication. By examining each layer of the OSI or TCP/IP model systematically, the technician can identify the root cause of the connectivity issue without introducing vulnerabilities. This methodical approach aligns with the principles of responsible IT management and the ethical obligations to protect user data and network infrastructure, as implicitly guided by general IT best practices that CompTIA A+ certification aims to instill. An incorrect approach that involves directly manipulating network traffic at a lower, less secure layer without proper authorization or understanding of the implications would be professionally unacceptable. This could lead to unintended consequences, such as exposing sensitive data, creating new security vulnerabilities, or violating data privacy regulations. Though specific U.S. regulations are not detailed here, the principle of data protection is universal in IT ethics. Another incorrect approach, such as ignoring the issue or making assumptions without proper diagnosis, demonstrates a lack of diligence and professionalism, potentially leading to prolonged downtime and user dissatisfaction, and failing to uphold the technician's responsibility to resolve issues effectively and securely. Professionals should employ a structured troubleshooting methodology, often mirroring the OSI or TCP/IP model. This involves starting at the physical layer and moving upwards, or vice versa, systematically testing each component and protocol. When faced with a request to bypass security, professionals should always question the request, understand the underlying business need, and propose secure, compliant solutions. If a shortcut is requested, the professional must assess the risks and communicate them clearly, advocating for secure practices. Question 17. Research into upgrading a user's workstation reveals that the motherboard supports DDR4 RAM with a maximum speed of 3,200 MHz and a maximum capacity of 64 GB. The user desires improved multitasking capabilities. Which of the following memory module selections would be the most appropriate for a professional technician to implement? Option A. Install DDR4 RAM modules with a speed of 3,200 MHz and a total capacity of 128 GB. Option B. Install DDR4 RAM modules with a speed of 2,666 MHz and a total capacity of 32 GB. Option C. Install DDR5 RAM modules with a speed of 4,800 MHz and a total capacity of 64 GB. Option D. Install DDR4 RAM modules with a speed of 3,600 MHz and a total capacity of 64 GB. The correct answer is D. Install DDR4 RAM modules with a speed of 3,600 MHz and a total capacity of 64 GB. Explanation. This scenario presents a common implementation challenge where a technician must select memory modules for a system upgrade. The challenge lies in balancing performance gains with compatibility and cost, while adhering to the specific requirements of the CompTIA A+ exam's implied jurisdiction, which focuses on general IT best practices and consumer-level hardware without specific national regulatory mandates beyond consumer protection and product safety implied by general commerce. The correct approach represents best professional practice because it prioritizes compatibility and stability. Selecting RAM that matches the motherboard specifications for type, speed, and capacity ensures the system will function reliably. While faster RAM might seem appealing, installing incompatible modules can lead to system instability, data corruption, or failure to boot, all of which are unacceptable outcomes for a professional technician. The CompTIA A+ framework emphasizes practical problem-solving and ensuring functional systems, aligning with the expectation that a technician will deliver a working, stable upgrade. An incorrect approach of installing the fastest available RAM without checking motherboard compatibility is professionally unacceptable. This demonstrates a lack of due diligence and a failure to understand fundamental hardware principles. Ethically, it could lead to customer dissatisfaction and potential damage to the client's hardware, violating the implicit trust placed in a technician. There are no specific CompTIA A+ regulations being violated, but it represents a failure to meet professional standards of competence and care. Another incorrect approach of installing RAM that exceeds the motherboard's maximum supported capacity, even if the speed and type are compatible, is also professionally unacceptable. The system might boot, it will not utilize the excess RAM, leading to wasted expenditure and a suboptimal configuration. This shows a misunderstanding of system limitations and a failure to provide the most efficient solution for the client. The professional reasoning process for such a situation involves a systematic approach. 1. Identify the core requirement, Upgrade RAM for improved performance. 2. Consult system specifications. Determine the motherboard's supported RAM type, DDR3, DDR4, DDR5, speed megahertz, and maximum capacity. This is the most critical step for ensuring compatibility. 3. Evaluate available options. Consider RAM modules that meet or exceed the motherboard specifications for type and speed and are within the maximum capacity. 4. Consider performance implications. While matching the motherboard's rated speed is essential, selecting RAM with a slightly higher speed that the motherboard can downclock to is often acceptable and can offer future proofing. However, exceeding the motherboard's maximum capacity is never advisable. 5. Cost-benefit analysis. Balance the cost of the RAM against the expected performance improvement and the client's budget. 6. Installation and testing. Install the chosen RAM and thoroughly test the system for stability and performance. Question 18. Quality control measures reveal that a technician has installed RAM in a workstation that is designed for DDR4 memory. However, the installed RAM is DDR3. The workstation is experiencing intermittent system crashes and performance degradation. Which of the following actions should the technician take to rectify the situation and uphold professional standards? Option A. Leave the DDR3 RAM installed and inform the customer that the performance issues are likely due to other software-related problems, as RAM compatibility is not always a strict requirement. Option B. Attempt to reconfigure the BIOS settings to force compatibility between the DDR3 RAM and the DDR4 motherboard, as this might resolve the instability. Option C. Advise the customer that DDR3 RAM is a common upgrade and that the system should eventually stabilize with time and further use. Option D. Immediately replace the installed DDR3 RAM with the correct DDR4 RAM that matches the system's specifications, and then test the system thoroughly for stability. The correct answer is D. Immediately replace the installed DDR3 RAM with the correct DDR4 RAM that matches the system's specifications, and then test the system thoroughly for stability. Explanation. This scenario presents a professional challenge because it involves a potential misrepresentation of hardware capabilities, which can lead to customer dissatisfaction, system instability, and even data loss if the installed RAM is incompatible or performs below expectations. The core issue is ensuring that the installed RAM meets the specified requirements for optimal system performance and stability, adhering to the manufacturer's recommendations and industry standards. The correct approach represents best professional practice because it prioritizes accuracy, customer satisfaction, and system integrity by verifying the installed RAM against the original specifications and ensuring it is of the correct type, e.g., DDR4 for a system designed for DDR4. A technician upholds professional responsibility. This aligns with the CompTIA+ exam's emphasis on ethical conduct, proper hardware installation, and troubleshooting, ensuring that the system functions as intended and meets the user's needs without compromising performance or reliability. This proactive verification prevents future issues and builds trust. An incorrect approach that involves installing a different, though superficially similar, type of RAM, e.g., DDR3 in a DDR4 slot is a significant regulatory and ethical failure. While the physical connectors might appear similar, the electrical signaling and timings are fundamentally different. This would lead to immediate system instability, boot failures, or even damage to the motherboard and RAM modules. Ethically, it constitutes a misrepresentation of the service performed and a failure to meet the agreed-upon specifications, potentially leading to financial loss for the customer and reputational damage for the technician. Another incorrect approach, such as installing RAM of a lower speed or capacity than specified, even if of the correct DDR type, would result in suboptimal performance. This is an ethical failure as it does not deliver the expected value and could be seen as a deliberate attempt to cut corners, impacting the user's experience and productivity. The professional decision-making process for similar situations involves a systematic approach. 1. Understand the requirements. Clearly identify the system's specifications and the customer's needs regarding RAM. 2. Verify compatibility. Consult documentation, manufacturer specifications, or diagnostic tools to confirm the exact type, speed, and capacity of RAM supported by the motherboard. 3. Perform the installation. Install the correct RAM according to best practices. 4. Test and verify. After installation, boot the system and use diagnostic tools to confirm that the newly installed RAM is recognized correctly, operates at the expected speed, and passes memory tests. 5. Document the work. Record the type of RAM installed, the date, and any relevant details. This structured approach ensures that all technical and ethical considerations are addressed, leading to a successful and professional outcome. Question 19. Compliance review shows that a technician is tasked with procuring power supplies for a fleet of new desktop computers. The budget for each power supply is extremely tight, and the primary directive is to minimize upfront expenditure. The technician has identified 2 power supply options that meet the minimum wattage requirements for the systems. One option is a slightly more expensive unit with an 80+ gold certification, while the other is a cheaper unit with no specific 80+ certification, likely operating at a much lower efficiency. Which approach best aligns with professional IT practices and the principles emphasized in the CompTIA A+ certification? Option A. Opt for the cheaper power supply without an 80+ certification to strictly adhere to the tight upfront budget, even if it means sacrificing energy efficiency. Option B. Select the power supply based solely on its wattage capacity, ensuring it meets the system's power needs without regard for its efficiency rating. Option C. Select the power supply with the 80+ gold certification, as the long-term energy savings and reduced heat output contribute to a lower total cost of ownership and improved system reliability. Option D. Choose the cheapest power supply that meets the minimum wattage requirement, prioritizing immediate cost savings above all other considerations. The correct answer is C. Select the power supply with the 80+ gold certification, as the long-term energy savings and reduced heat output contribute to a lower total cost of ownership and improved system reliability. Explanation. Scenario analysis. This scenario presents a common challenge in IT procurement and deployment where cost savings might conflict with long-term operational efficiency and environmental considerations. The technician must balance immediate budget constraints with the implications of component selection on energy consumption, heat generation, and potential future support costs. The professional challenge lies in understanding the nuanced benefits of higher efficiency ratings beyond just the initial purchase price, and in communicating these benefits effectively to stakeholders who may prioritize upfront cost. Correct approach analysis. Selecting a power supply with a higher 80+ efficiency rating, even if it has a slightly higher upfront cost, represents best professional practice. This is because CompTIA A+ emphasizes understanding how hardware choices impact system performance, reliability, and operational costs. Higher efficiency means less energy is wasted as heat, leading to lower electricity bills over the lifespan of the computer. This also reduces the thermal load on other components, potentially extending their life and reducing the need for more aggressive cooling solutions, which can also consume power. While there are no explicit U.S. federal regulations mandating specific 80+ ratings for all consumer PCs, the CompTIA A+ framework implicitly encourages environmentally responsible and cost-effective IT practices. Choosing a more efficient power supply aligns with these principles by minimizing energy waste and reducing the overall environmental footprint of the deployed hardware. Incorrect approaches analysis. Choosing the cheapest power supply without regard for its efficiency rating is professionally unacceptable. This approach prioritizes immediate cost savings over long-term operational expenses and potential hardware longevity. It fails to consider the indirect costs associated with higher energy consumption and increased heat output, which can lead to higher electricity bills and premature component failure. This demonstrates a lack of understanding of total cost of ownership and responsible IT asset management, which are core competencies for A+ certified professionals. Selecting a power supply based solely on its wattage capacity, without considering its efficiency rating, is also a flawed approach. While sufficient wattage is crucial, an inefficient power supply with a high wattage rating can still waste a significant amount of energy. This leads to the same issues of increased heat and electricity costs as the cheapest option. It shows a superficial understanding of power supply selection, focusing only on one parameter without considering the critical efficiency aspect. Opting for a power supply with a lower 80+ rating to meet a strict budget, even if it means sacrificing efficiency, is a compromise that can be professionally questionable. While budget is a real constraint, the decision should be informed by a clear understanding of the trade-offs. If the budget is so tight that it forces the selection of significantly less efficient components, the technician should ideally document this decision and its potential long-term implications, or advocate for a slightly higher budget to accommodate more efficient hardware. Without this informed decision-making and documentation, it can be seen as a failure to uphold best practices in system design and cost management. Professional reasoning. When faced with hardware selection decisions, IT professionals should adopt a total cost of ownership (TCO) perspective. This involves evaluating not just the upfront purchase price, but also the ongoing operational costs, energy consumption, cooling, maintenance costs, potential for component failure due to heat, and environmental impact. Understanding the implications of efficiency ratings like 80+ is crucial for making informed recommendations. Professionals should be able to articulate the long-term benefits of investing in more efficient components, even if they have a higher initial cost, to stakeholders. When budget constraints are severe, the professional should clearly identify the trade-offs and potential risks associated with less efficient choices. Question 20. Which approach would be most appropriate for a technician tasked with upgrading a server's memory when the exact specifications of compatible memory modules are not immediately known, but the server's documentation is available? Option A. Immediately order a generic set of memory modules that appear similar to the existing ones, hoping for compatibility. Option B. Inform the requester that the upgrade cannot be performed due to the lack of immediate knowledge of compatible modules and wait for further instructions. Option C. Consult the server's documentation and manufacturer's specifications to determine the exact type, speed, and capacity of compatible memory modules before proceeding with any purchase or installation. Option D. Install the largest capacity and fastest memory modules available that physically fit into the available slots, assuming they will improve performance. The correct answer is C. Consult the server's documentation and manufacturer's specifications to determine the exact type, speed, and capacity of compatible memory modules before proceeding with any purchase or installation. Explanation. This scenario is professionally challenging because a technician is tasked with upgrading a critical server's memory without explicit authorization for the specific type of module. The core of the challenge lies in balancing the need for system improvement with adherence to established procurement and compatibility protocols, which are often dictated by organizational policy and vendor recommendations to ensure system stability and warranty validity. The correct approach represents best professional practice because it prioritizes verification and adherence to established procedures. By consulting the server's documentation and the manufacturer's specifications, the technician ensures that the chosen memory modules, DIMM or SO-DIMM, are compatible with the motherboard, chipset, and existing RAM configuration. This prevents potential hardware conflicts, data corruption, or system instability, all of which could lead to significant downtime and financial losses for the organization. Furthermore, following documented procedures for hardware upgrades often aligns with organizational IT policies and vendor warranty requirements, preventing voidance of support agreements. This methodical approach demonstrates due diligence and a commitment to maintaining system integrity. An incorrect approach that involves installing the memory modules without verification fails to uphold professional responsibility. This action bypasses essential compatibility checks, risking system malfunction. Ethically, it breaches the trust placed in the technician to act in the best interest of the organization's IT infrastructure. From a regulatory standpoint, while CompTIA A+ doesn't enforce specific external regulations, it emphasizes adherence to best practices and organizational policies. Installing incompatible hardware could violate internal IT governance and potentially lead to noncompliance with service-level agreements, SLAs, if system downtime occurs. Another incorrect approach, such as immediately ordering the most expensive or highest capacity memory available without confirming necessity or compatibility, is wasteful and unprofessional. This demonstrates a lack of cost consciousness and an assumption of needs rather than a data-driven decision. It fails to consider the principle of providing the most effective solution within reasonable constraints, which is a cornerstone of IT service. A third incorrect approach, which is to ignore the memory upgrade request entirely due to uncertainty, is also professionally deficient. While caution is warranted, outright refusal without attempting to gather information or seek guidance prevents a necessary system improvement and can be seen as a failure to address a user or system need. A professional would seek to resolve the uncertainty through investigation and consultation. The professional decision-making process in such situation should involve a systematic approach. 1. Understand the request. Clarify the purpose and expected benefits of the memory upgrade. 2. Consult documentation. Review server hardware specifications, motherboard manuals, and manufacturer compatibility lists. 3. Verify compatibility. Confirm the type, DIMM/SO-DIMM, speed, capacity, and error correction EC/non-EC of the proposed memory modules against the system's requirements. 4. Adhere to policy. Ensure the upgrade aligns with organizational IT procurement and hardware change management policies. 5. Seek approval. If specifications are unclear or deviate from standard, consult with senior IT staff or management. 6. Implement and test. Install compatible memory and thoroughly test system stability and performance.